Welcome to the vast expanse of the universe. Today, we embark on an extraordinary journey to explore one of its most awe-inspiring structures, the Great Wall of Galaxies. But what exactly is this monumental structure? How was it uncovered by dedicated astronomers, often working against the vastness of space and time? And why is it so vital to our understanding of the cosmos? Prepare to dive deep into the mysteries of our universe, where every answer opens the door to even more questions. The Great Wall of Galaxies refers to colossal structures composed of clusters and superclusters of galaxies, intricately linked by vast filaments of dark matter and gas. Imagine the universe as a vast ocean, with galaxies acting as islands connected by invisible currents. These immense walls serve as the very backbone of the universe, showcasing how matter is distributed on a cosmic scale. Take, for example, the Sloan Great Wall. Spanning over 1.4 billion light-years, this colossal cosmic structure contains thousands of galaxies, each swirling with its own stars, gas, and potentially habitable planets. To truly grasp the enormity of this structure, visualize it. If our Milky Way galaxy were the size of a grain of sand, the Sloan Great Wall would stretch as long as a football field. This immense scale prompts profound questions about the nature of our universe. How did such structures form? What do they reveal about the fundamental forces that govern the cosmos? And how do they influence the galaxies within them? Historical footage of telescopes, early astronomical surveys, and computer simulations of galaxy distributions. Narrator: the quest to uncover these monumental structures began in earnest during the late 20th century. The advent of powerful telescopes and advanced imaging techniques allowed astronomers to probe deeper into the cosmos than ever before. The Sloan Digital Sky Survey, initiated in 2000, became a pivotal project in this endeavor. This ambitious survey aimed to create a comprehensive three-dimensional map of the universe by utilizing state-of-the-art imaging technology and an extensive database of observations. With over 14 million objects cataloged, including nearly 1 million galaxies, the project provided an unprecedented view of the universe. Through meticulous observation and analysis, astronomers unveiled the Great Wall and its companions, revealing a striking pattern of interconnected structures that had previously gone unnoticed. This groundbreaking work not only transformed our understanding of the universe's architecture, but also raised critical questions about how galaxies form, evolve, and interact. It was a moment akin to discovering a hidden layer of reality, unveiling the intricate design of the cosmos. But why are these structures so significant? The Great Wall of Galaxies provides critical insights into the formation and evolution of the universe. By studying these colossal structures, astronomers can learn how matter is distributed on a cosmic scale, revealing the intricate tapestry woven by gravitational forces over billions of years. The presence of such walls indicates that galaxies are not dispersed randomly throughout space. Rather, they are shaped and influenced by gravitational forces that draw them together. This gravitational interplay is essential for understanding galaxy formation. For example, when galaxies collide, they don't just pass by each other. Instead, they interact, merge, and often trigger bursts of star formation. This phenomenon, known as galactic cannibalism, occurs when a larger galaxy consumes a smaller one, reshaping the cosmic landscape in the process. Moreover, the study of these walls allows scientists to probe the nature of dark matter, as its gravitational effects are crucial in the formation of these structures. The intricate web of galaxy clusters and walls forms what is known as the cosmic web, a vast structure that underpins the universe, revealing the influence of dark matter and dark energy in cosmic evolution. Understanding these interactions helps astronomers refine their models of the universe and offers insights into how the universe has evolved over billions of years. By mapping the Great Wall and its surrounding structures, we can trace back the history of galaxy formation and gain clues about the fundamental processes that shape our cosmic environment. At the heart of the Great Wall's formation lies dark matter, an elusive substance that constitutes about 27% of the universe's mass energy content. While it remains invisible to our instruments, its gravitational effects are undeniably profound. Dark matter acts as the unseen architect of the cosmos, shaping the structure of the universe in ways we are only beginning to understand. Imagine dark matter as the invisible framework of a skyscraper. Without it, the galaxies we observe would drift apart, unable to form the intricate structures that populate our universe. The gravitational pull of dark matter is what holds galaxy clusters together, providing the stability necessary for their formation and evolution. Research into dark matter is ongoing and critical. Scientists are exploring various theories about its nature, including the possibility that it is composed of exotic particles, such as weakly interacting massive particles, WIMPs or axions, that do not interact with normal matter except through gravity. Understanding dark matter is not just a matter of curiosity. It could unlock fundamental secrets about the universe, such as the nature of gravity itself and the very fabric of space-time. In addition, experiments conducted in laboratories on Earth, such as those at the Large Hadron Collider, aim to uncover the fundamental particles that might make up dark matter. As we continue to explore the nature of this mysterious substance, we move closer to answering some of the most profound questions in cosmology. As our understanding of the universe continues to evolve, research into these grand structures is more vital than ever. The upcoming James Webb Space Telescope, poised to revolutionize our exploration of the cosmos, represents a monumental leap forward. Equipped with cutting-edge instruments, Webb will allow us to observe the formation of galaxies and their environments in unprecedented detail. This powerful telescope aims to delve into the early universe, shedding light on the formation of the first galaxies and the processes that shaped the cosmic landscape. It will provide invaluable data on the atmospheres of exoplanets, search for the building blocks of life, and explore the conditions necessary for star formation. Furthermore, ongoing projects like the European Space Agency's Euclid mission aim to map the distribution of dark matter and understand the universe's expansion. This mission will utilize advanced techniques to observe billions of galaxies and provide new insights into the mysterious forces that drive cosmic evolution. By studying the Great Wall of Galaxies and other cosmic structures, scientists hope to unravel the mysteries of our universe, addressing profound questions about its origins, evolution, and ultimate fate. The potential discoveries could reshape our understanding of the cosmos and redefine our place within it. As we gaze into the depths of the cosmos, the Great Wall of Galaxies serves as a stunning testament to the grandeur and complexity of the universe. Each discovery enriches our understanding of this cosmic tapestry, revealing the intricate connections that bind us to the stars. So whether you're an aspiring astronomer, a student of the cosmos, or simply a curious soul, remember that the universe is a treasure trove of mysteries waiting to be uncovered. Each exploration brings us closer to understanding our place in this magnificent cosmos. Thank you for joining us on this enlightening journey. Stay curious, keep asking questions, and never stop looking up at the stars.